Alright, next let's have a look at the last types of functions we're going to review, which are called inverse trigonometric functions. So we'll have a look at inverse sine, cosine, and tangent. And for the secondary trigonometric ratios, we're not going to review it here because they're just reciprocal of the primary ratios, so you can use similar concept to study them. Okay, so our focus should be put on the inverse sine, cosine, and cotangent, and tangent. So first of all, inverse sine. Remember, any function has an inverse, right? But the inverse of a function does not have to be a function. Only in the case where the inverse of a function also satisfies the definition of function, we can call the inverse of a function also functions. So note that the inverse of a function has a graph which is symmetrical with the original function in the line y equals x, right? Because sine x is a periodic function, if you simply find its inverse, then its inverse will have a graph like this. If you consider all the periods, then the inverse of sine will look like this. Well, actually, this is not a function, right? Because it does not satisfy the vertical line test. For any input, we will have more than one output corresponds to the inverse of sine. Therefore, in order for the inverse of sine to be a function as well, we need to confine its interval to this, from negative half pi to half pi. If you only consider this interval, the inverse of sine also has a property that a function has, in which input corresponds to only one output. Okay, so when you see this notation here, y equals arc sine, or y equals inverse sine of x, this means the following three things. First of all, y is an angle in radian measure, and this angle is in the interval between negative half pi to positive half pi, closed interval. And last, the sine value of y equals x. So this is the interpretation of inverse sine or arc sine. Its graph is illustrated here. Okay, try to memorize this graph because we're going to use it when we discussing the derivative of arc sine. Main properties of arc sine includes the following. First, the domain of this function is from negative 1 to positive 1. Range is from negative half pi to positive half pi. It's also an odd function because we can prove arc sine negative x equals negative sine x, and its graph has point symmetry in the origin point. Its y-intercept is 0, 0, and x-intercept is also 0, 0, and it's the interval from negative 1 to positive 1, closed interval, is this increasing interval. Function is increasing monotonically in this interval. And we have the following inverse property. If alpha is between negative 1 and positive 1 in closed interval, then we always have sine of arc sine alpha equals alpha, because we know that's an angle between negative half pi and positive half pi, such that the sine value of that angle equals alpha. Therefore, if you put another sine function in front of it, sine of that value, sine of that angle, of course, will give you alpha, right? And if beta is between negative half pi to positive half pi, then we always have arc sine of sine beta equals beta. Because, again, we know that's actually an angle such that the sine of that angle equals sine beta. When beta is between negative half pi and positive half pi, we can directly know that angle is actually beta itself. Otherwise, if beta is not in that interval, you need to convert beta into negative half pi to positive half pi by using coterminal angle expressions. That means you need to plus or you need to use beta plus 2k pi, where k belongs to a linear set. Did you get it? Again, the most important thing is to understand the graph of arc sine. Okay. All right. let's have a look at some examples to check your understanding. Can you find the exact value of each of the following expressions without using technology? Which means you have to calculate each of the expressions manually. So first of all, first question, arc sine value. So this means an angle, right? This means an angle such that sine value of that angle equals this value here. And this angle is between negative half pi and half pi, right? So can you find such an angle in that interval? So this is an angle between negative half pi to positive half pi, such that sine of that angle equals negative square root 3 over 2. So we know that angle must be somewhere here, right? And specifically that angle should be negative third pi. Can you see that? Because we know sine negative third pi will give you negative square root 3 over 2. Therefore, arc sine negative square root 3 over 2 should equal negative third pi, right? So that equals negative third pi. Did you get it? Alright, let's have a look at the second one. Second one is also an angle such that this angle is between negative half pi and half pi. And the sine value of that angle equals 3 over 2. And this is impossible because we know sine is between negative 1 half and positive 1, right? So this is not defined. We can write undefined. This is why we call the domain of arc sine is from negative 1 to positive 1. And if you have a number that is out of that interval, then there is no output. Okay, next one. Sine of a angle. So this is an angle, right? You want to evaluate the sine of that angle. And note that this is an angle such that this angle is between negative half pi to half pi. And sine of that angle equals 1 over 2. Therefore, if you want to evaluate sine of that angle, of course that equals 1 over 2, right? Did you get it? Okay, how about the last one? Last one is a angle such that the angle is between negative half pi and positive half pi, and sine of that angle equals sine a quarter pi, right? And we know in that interval we can find a angle a quarter pi, which satisfies this condition. So that gives you a quarter pi here. Did you get it? Okay, let me check your understanding by add another question here. So how about arc sine, let's say sine let's try another one. How about 5 pi over 6? Alright, let's have a look at the solution. So does it equal 5 pi over 6? No, it doesn't, because we know arc sine is the angle between negative half pi and half pi, right? So we cannot just write 5 pi over 6 because that angle is not within that interval. So basically that means three things. If you have an expression like this, that means three things. First of all, this is the angle, so let's call it theta. And second, theta is between negative half pi and half pi, right? Which means theta is within this interval from negative half pi to half pi. And third, we know sine of that angle theta equals the value here, no matter what it is. So in that case, that's sine 5 pi over 6. So the problem is you need to find an angle theta between negative half pi to half pi such that sine of that value equals sine 5 pi over 6, right? So where is 5 pi over 6? 5 pi over 6 is somewhere here. That's 5 pi over 6. So that means, can you find the angle in this interval between negative half pi to positive half pi such that the sine value of that angle equals sine 5 pi over 6? So according to symmetry, apparently we can find the angle here, which is 6 pi, such that sine this value equals sine 5 pi over 6, right? That's why we know the result is a 6 pi, not 5 pi over 6. Okay? Make sure you can solve this by yourself. Any questions? No? Okay, so next let's have a look at the inverse cosine function. So similarly, when you see the notation y equals arc cosine x or y equals inverse cosine x, that means three things. First, y is a angle, right? And then y is between 0 and pi. So be careful, the interval we select here is different with the one in arc sine or sine. So this time we fix the y from 0 to pi. So in that interval we know cosine has a 1-to-1 mapping relation, right? So in that case, the inverse cosine is also a function. And third, cosine y equals x. So according to the definition, we know the domain is from -1 to +1. Range is from 0 to pi, closed interval. And this arc cosine or inverse cosine is neither odd or even. We know this is graph. You can easily see the graph is not symmetrical in the y-axis or has point symmetry in the origin point. So this function is not odd function or even function. And it has a decreasing interval from -1 to 1. And also we have inverse property like this. First, if alpha is between -1 and +1 inclusive, then we have cosine arc cosine alpha always equals alpha. And secondly, if beta is between 0 and pi inclusive or closed interval, then we have arc cosine of cosine beta equals beta. Otherwise, if beta is not within this interval, you need to convert beta into the correct interval such that the cosine of that angle equals cosine beta. Okay? Okay, again, let's have a look at an example to check your understanding. Can you find the exact value of each of the following expressions without using technology? The first one is the angle, right? Such that this angle is between 0 to pi. So in this interval, from 0 to pi, right? And such that this angle has cosine, cosine of that angle gives you square root 2 over 2. So can you find any angle in this interval whose cosine is square root 2 over 2? So apparently we know that angle is here, right? Which is a quarter pi. So we know that's a quarter pi. Did you get it? How about the next one? Inverse cosine of cosine 4 pi over 3. Again, this means a angle, right? Such that the cosine value of that angle equals cosine 4 pi over 3. And this angle must be between 0 and pi, right? And we know 4 pi over 3 is pi plus another third pi, which is here. So that's 4 pi over 3, right? So can you find an angle between 0 and pi such that cosine of that angle equals cosine 4 pi over 3? Apparently we know, according to the symmetry, we know that angle is somewhere here, right? So what is the value of that angle? That's 2 pi over 3, right? Why? Because if you have 4 pi over 3 here, this angle here gives you a third pi. Then that angle here gives you a third pi. So of course, this angle is pi minus the third pi, which is 2 pi over 3, right? Alright, if you don't have any questions, let's have a look at the next one, which is inverse tangent. So inverse tangent is defined as this. If you have a if we see y equals arctangent or y equals inverse tangent of x, that means three things. First, y is the angle. And next, y is between negative half pi to positive half pi. But this time, we have an open interval because tangent x is not defined in either end, right? And last, tangent y equals x. And this graph is plotted in the left diagram here. Again, the inverse tangent has line symmetry with its rational function y equals tangent x in the line y equals x. And make sure you know the main properties of arctangent as well. If you don't have any questions, let's use some examples. Check your understanding. Can you find the exact value of each of the following expressions without using technology? First, what is arctangent square root 3? So first of all, this is the angle, right? This angle is between negative half pi to positive half pi. And tangent of that angle gives you square root 3, right? So can you find this angle in this interval? So we know that angle should be somewhere here, which is third pi, right? So we can write arctangent square root 3 is actually a third pi. Did you get it? So how about the next one? Tangent a angle. This is the angle such that this angle is between negative half pi to half pi, and tangent of that angle gives you negative 7, right? So if you want to find tangent of that angle, of course, that'll give you negative 7. Did you get it? Okay, second question, which actually asks you to find tangent of an angle such that this angle's tangent is negative 7. So therefore we know the tangent of that angle should give you negative 7, right? Okay, any questions? No? Okay, let's have a look at the last key point in the trigonometric functions. Make sure you're able to solve a trigonometric equation. A trigonometric equation is one that involves one or more of the 6 functions, namely sine, cosine, tangent, cotangent, secant, and cosecant. Some trigonometric equations like x equals cosine x can be solved only numerically through successive approximations, but a great many can be solved analytically in a closed form, an exact solution in symbols. There are 2 things you need to be careful with. First, there might be multiple solutions, so ensure you can find all solutions that lie in the domain of interest. And second, pay special attention for any restrictions when solving the problem. For example, which interval the angle is in. Okay? Again, I'll use an example to illustrate the concept. So suppose we have a trigonometric equations like this. Can you find all possible values of x that satisfy this equation? That's the first question. And then, second question asks you to find specific x that satisfy the above equation, and x is between this interval. Can you see the difference? In the first question, we do not have any constraints for x, so we need to express all possible x that satisfy this equation. And in the second question, you need to find a specific value of x in this interval. Okay? I'll give you some time to consider this, and we'll have a look at solutions together. Okay? Okay, let's have a look at the solution together. So, first of all, we can convert cosine x squared to 1 minus sine x squared, right? So that's a function in terms of sine x. So we can simplify that to 2 sine x squared minus sine x plus 1 equals 0. Then we can further factorize to 2 sine x plus 1 times sine x minus 1 equals 0, right? Therefore, we have 2 solutions. Sine x is either negative 1 over 2, or sine x can also be positive 1, right? Then we can consider them separately, so we label them as 1 to 2. So according to expression 1, that means x is an angle such that sine of that angle equals negative 1 over 2. So can you find such an angle in, for example, 1 period first? Then we can express all the angles by add a plus 2k pi, right? So if we consider 1 period, then we know sine is negative, so that angle must be somewhere here or here, right? Such that sine of that angle gives you negative 1 over 2, right? And according to symmetry, we know that sine 6 pi will give you 1 over 2. So you can easily find an angle whose sine is negative 1 over 2, which is negative 6 pi, right? We can find one angle there. And how do you find this angle here? So this angle is the 6 pi plus another pi. So we can express that angle to 7 pi over 6. So as long as you can find two angles, then basically that's it. So we can express all the angles by adding a 2k pi. So from equation number 1, we get x equals either negative 6 pi plus 2k pi, where k belongs to the integer set, or x can also be 7 pi over 6 plus 2k pi, where k belongs to the integer set, right? And from the second equation, we know we need to find an angle whose sine gives you 1. And we know that sine half pi will give you 1, right? So in one of the periods, you can find only one angle whose sine is 1. So all the angle can be expressed as x equals half pi plus 2k pi, where k belongs to the integer set. So basically, that's the solution to the first question. You get it? Oh, sorry, there's a typo here. That should be minus 1, right? Alright, then as to the second question, it asks you to find exact x such that x must be in this interval. So you need to test different k values such that x must be within this interval, right? The easiest one is we test different k values such that x must be within that interval. So the easiest one is we let k equal 0. If k equals 0, we have x equals, the first solution here will give you negative 6 pi, so that's out of the boundary, so we do not take that. But the second solution will give you 7 pi over 6. So we can take this because 7 pi over 6 is between 0 to 2 pi, right? And then the next one will give you x equals a half pi, which also satisfies the condition. Then you can test either side. For example, let's test k equals 1, 2, 3, 4, and so on. If k equals 1, the first solution here will give you 2 pi minus 6 pi, which is 11 pi over 6, right? You can take that because that's also within that interval. But the next one will be out of the boundary. If k equals 2, the first one will be out of boundary and second one will be out of boundary as well. So you do not need to test any number that is greater than 1, right? Then consider the other side, k equals negative 1. So this value is less than 0, and the next one is also less than 0, and this one is less than 0. So we do not test any value that is less than 0. So the only solution is these three solutions: x equals 7 pi over 6, a half pi, or 11 pi over 6. Did you get it? So have a look at the solution here. This is nicer writing the solutions, okay? Okay, so that's the end of topic 1, and that's the basis to learn the next topic, limits and differentiation. So we'll have a look at topic 2 in our next lesson.